Welcome to Mrs. Neller's notes for her double block algebra class. These are the notes for section 10.5 entitled Factoring x squared plus bx plus c. And what that means is we're going to factor trinomials, and we're going to factor them in the form of x squared plus bx plus c. That means that there's not going to be any a term in front of the x squared. So this is the easy factoring that we're going to be doing today. Now, when you factor a trinomial, that means that you take the sum of three terms, so it could be addition and subtraction, but you take three monomials that you've added or subtracted together, and you rewrite it as a product of two binomials. So you're changing addition and subtraction into multiplication. Okay? Now there are a lot of different ways that we can do this. We can do guess and check, that's the most common way, or we can do box, that's probably the second most common way. There's also a triangle method that we can show you, or a crisscross method that we can show you. But we're going to show you those later because those work better with a lead coefficient in front of the x squared. But today I will show you the guess and check and the box method. Now, whatever method you use, you have to know the factors of that last term. So you have to know the factors of the C term that are going to add up to the B term. So we have to be really good at our multiplication facts here. So let's just try the guess and check method and the box method with this trinomial here. The x squared plus 9x plus 14. So if we're going to do our guess and check, I'll just call it G and C. We're going to have our x squared plus 9x plus 14. Now we need the factors of 14. So sometimes when we're starting this off, students make a little list, like 1 times 14 and 2 times 7. Now you could also write down 7 times 2 and 14 times 1, but they're the same pairs as what we have written here. Okay? Now, once you have your list of all of your factors, all the terms that you can multiply together to get 14, then you have to look at them and you have to say, okay, which of those factors will add up to my middle term, the 9x? Is there any way that I can make 1 and 14, either with addition or subtraction, somehow get me to 9? Nope. Is there some way that I could get 2 and 7 with addition or subtraction to get me to 9? Yes, I could add them. So that's what we're going to do when we write our factored form. Now the factored form is always going to have parentheses that are being multiplied together. And these are always going to start with an x and an x. When we get into the ones that have an a term, there will be a number in front of one or both of the x's. But for now, it's just going to be x and x. Then I'm going to put these two factors in, the 2 and the 7, because those are the factors I want that will multiply together to be 14, but add together to be 9. And the way I get them to add up to 9 is if I do 2 plus 7. So I need them both to be positive. And there is my factored set of binomials. Now, the box method is basically the same thing except you use a box. And you set it up so it kind of looks like a lattice, but we're not going to have those little diagonals. And your first term, the x squared, is going to go in the first box. And your last term, the 14, is going to go in the last box. And you still need your factors of 14. So you can have 1 and 14, or you could have 2 and 7. And again, we still want to find ones that are going to add up to 9. So again, we can't use the 1 and the 14. We have to use the 2 and the 7. So then I'm going to put a 2x and a 7x in these boxes. It doesn't matter where you put the 2 or where you put the 7. Doesn't really matter. Now what you have to do is you have to look at this box vertically and horizontally. So when I look at it horizontally, I need to look at each row and say, okay, what's the GCF for these terms in this row? So if I look at this first row, I have x squared and 7x, and their greatest common factor is an x. So I'm going to write that out front here. And in my bottom row, the 2x and the 14, their greatest common factor is a 2. So I write that out front. Then for these columns, I look at them and say, okay, what's their GCF? I have an x squared and a 2x, so their GCF will be an x. You can either write it up at the top or you can write it down at the bottom, doesn't matter. And then we have the 7x and the 14, and again, their GCF is going to be a 7. Now it was a positive 7 and a positive 2 that I pulled out for my GCF. So now if I go around the corners of the box here, around those sides, I just rewrite those binomials in parentheses, and I have my factored form. Okay, so the box method probably isn't as efficient time-wise because there's a lot more that you have to set up, but it's a very good structure for students who need a step-by-step process in order to be successful with the factoring. And it works super well when we have a lead coefficient in front of the x squared term. Or if we have bigger numbers, instead of needing the factors of 14, if you needed the factors of 350, the box method can be much more helpful for that than the guess and check. But they get you the same answer. So you can do whichever method you prefer. Most of the time I do the guess and check, just because that's my preferred method. But at any time, if you want to see the box method or any of the other methods, the triangle and crisscross, we can show you those as well. But usually the guess and check and the box are the most preferred for students. Okay, so we have a couple examples. We have example 1, then we have example 2. So example 1 here, we're just going to practice factoring with a variety of different trinomials. Now, if you look, notice we've got all 4 different sign combinations. We've got a plus and a plus, and a minus, and then we have a plus minus and a minus plus. So you're going to have an example of factoring pretty much every combination of signs that exists for these trinomials. Now, there are some patterns that are going to happen here with the signs that go into the parentheses. So again, if you pay attention and notice these patterns, it can help you factor. But really, if you know the guess and check strategy and you know the box method strategies, you're going to get the right signs every time. So you don't necessarily have to know these sign patterns. But when we're factoring our trinomial, we always need the factors of the last term that will add up to the middle term. So here I need the factors of 6. So that could be 1 and 6, or it could be 2 and 3. Now 1 and 6, no matter how I add up 1 and 6, well, I guess I could subtract them to get a 5, but then I would have a subtraction. And a subtraction, if I put a minus in one of my parentheses, it means I'm going to get a minus here when I multiply. So I'm not going to use the 1 and 6. If I use the 2 and the 3, those will add up to 5 if I make them both positive. And if I multiply them, they will multiply to a positive 6 as well. So I need the x, and the 2, and the 3, and I need them both to be positive. Now, if you want to check your work, you can. You just have to FOIL this back out. So you'd have to take x times x, which would be x squared, And then x times 3 is 3x. 2 times x is 2x. And 2 times 6, or 3 is 6. So then you get x squared plus 5x plus 6. So the stuff in blue is my answer. The stuff in red would be me checking my work. Okay? So you can see here, when we have all 4 of these terms written out, you can see that the 2 and the 3 have to add together to be 5. That's my middle term. And then the 2 and the 3 have to multiply. The 2 and the 3 up here in parentheses have to multiply together to get me my last term, which is a 6. So checking our work here really sees why we need to multiply to the last term but add to the middle term. Okay, now for part B, I have x squared minus 7x plus 12. So I need the factors of 12. So I could have 1 and 12, 2 and 6, 3 and 4. And then I'm going to need a combination that gets me to a negative 7 somehow. 1 and 12 will not get me to a 7. They'll get me to a 13 or an 11. 6 and 2 could get me to an 8 or a 4. But 3 and 4 can get me to a negative 7 if I make both of them negative. So when I set up my parentheses, put in my x and my x, my 3 and my 4, and then I'll make both of them negative. So again, if I distributed, I'd get x squared minus 4x minus 3x. So minus 3x and minus 4x would be a minus 7x. And then negative 3 times negative 4 would be a positive 12. So I'm not going to write in that step where I do the distribution to check it, because sometimes if I do that a lot, students think that that's actually part of the problem and part of the work, and it's not. This green and then in parentheses, that's your answer. That's where you stop. If you want to check the work, you can, but that's not really part of the answer. That's just checking the answer. Okay, now part C, we're going to have to find the factors of 10 that add up to negative 3. So I could have 1 and 10, or 2 and 5. Okay, 1 and 10 will either get me to a 9 or an 11. So that's not going to get me to the negative 3. 2 and 5, though, those could get me to a negative 3. So I set up my parentheses, my x and my x, my 2 and my 5. Now, in order to get to a negative 3, to add up to a negative 3, the 2 would have to be positive and the 5 would have to be negative. And then if I multiply them, 2 times negative 5 would get me negative 10. So hopefully by now you're starting to catch on to the guess and check method here and see how these numbers have to multiply and add together. Okay, let's do one more. For part D, I need the factors of 20. It's always the factors of the last term that add up to the middle term, so they have to add up to 8. So I could have 1 and 20, I could have 2 and 10, I could have 4 and 5. I think that's all of them because then we'd start to repeat. 1 and 20 will either add or subtract to 21 or 19, so that's not going to help me. 2 and 10, if I did 10 minus 2, that could get me to an 8. And the 4 and the 5, that would either get me to a 9 or a 1. So I don't want the 4 and the 5. I want the 2 and the 10. So I'm going to set up my parentheses, x and x, 2 and 10. And then the way that I get 2 and 10 to add up to 8 is that the 10 has to be positive and I have to subtract the 2. So 10 minus 2 is 8, and then negative 2 times positive 10 is that negative 20. Okay, so the only other thing we're going to do now for example 2 is we're going to factor and then solve the equation. So we're going to combine what we did in section 10.4 with what we're doing now in 10.5 with the factoring. So you'll notice that I still have a trinomial, except now it's set equal to 0. So I have x squared plus 4x plus 3 equals 0. So I still want my last term to be the factors that I find. So I need the factors of 3 that are going to add up to 4. So I just kind of ignore that little equals 0 for now when I'm doing my factoring. So I'm still going to factor like we did in example 1, and then once I get it factored, I'll set it equal to 0. So I'll write the equal 0 at the end. So I need the factors of 3. Well, that's just 1 and 3. Okay, so that's pretty much my only option. So I have x and x, I have a 1 and I have a 3, and 1 and 3 will add up to 4 if I make them both positive. And 1 times 3 is 3. So I have my correct factored form. Now I'm going to set it equal to 0. And now this should look very, very familiar. I have two little parentheses. They're both set equal to 0. So I'm going to set each one equal to 0 and solve. I subtract the 1 over, so I get x equals negative 1. I subtract the 3 over, so I get x equals negative 3. Now again, hopefully you notice that my answer is basically the opposite of the numbers that I put in the parentheses. I had a plus 1 and a plus 3, and my answers are negative 1 and negative 3. That's going to happen every time. That sign is going to be opposite. So as you do more and more of these, you'll get really good at going from this part where we have the factored equation right to the answer. But again, if you need to set each little parenthesis equal to 0 and do the work and solve them, that's totally fine. Do that. We like to see all that work. Now part B is a little bit different because it's not set equal to 0 first. So we have to make sure that we do that. We have to make sure that we're setting our equation equal to 0 before we factor. So I have my x squared and my minus 5x, but I need this 6 to be on the other side as well. So I'm going to subtract him over. So now I'll have x squared minus 5x minus 6 equals 0. So now I have my trinomial. It's in descending order. I'm going to need the factors of 6 because that's my last term before that little equals 0. So I could have 1 and 6, or I could have 2 and 3. Now 6 is probably one of the trickier numbers because a lot of times they give you 6 and then they give you 5. And you really have to pay attention. We had that when we started off up here in example 1 part A. We had a 6 and a 5, and you have to pay attention to the positives and the negatives and which combination you want. So that way they're adding to the appropriate number with the appropriate sign, and they're multiplying to the appropriate number with the appropriate sign. Okay, so when I set up my parentheses, I'm going to need an x and an x. And now I got to think, okay, 1 and 6, they could get me to a negative 5 if I made the 6 negative. And then 1 times negative 6 would be a negative 6. 2 and 3, though, could also get me to a negative 5 if I made them both negative. But when I multiply a negative and a negative, that gets me a positive. So I don't want the 2 and the 3. I want the 1 and the 6 because then I can make the 6 negative and the 1 positive. So this combination will add to the negative 5 and multiply to the negative 6. So you really have to pay attention to which numbers and which signs when you're dealing with the factors of 6. So then I'm going to set each little parenthesis equal to 0, and then I will solve. So x equals negative 1, and then x equals 6. So again, my answers have the opposite signs of what I put in the parentheses. Okay, now for part C, it's our last one. Again, it's not set equal to 0 to begin with, so I have to do that. I'm going to subtract the 13x over. Now I don't have any other x terms to combine it with, so it's just x squared minus 13x plus 42. Now my last term here is the 42, so that's what I'm going to need the factors of. I need the factors of 42. So I could have 1 and 42. I could have 2 and 21. I could have 3 and 14, I believe. I could, not 5. I could have 6 and 7. And I need a combination that's going to get me to 13. So it's not the 1 and 42, not the 2 and 21. 3 and 14. Oh, I could get to 17 or 11. There we go. 6 and 7. 6 and 7 will add up to 13. And if I make them both negative, they will get me to a negative 13. So I need an x and an x, and a 6 and 7, and they both need to be negative. So that way they add to a negative 13, but multiply to a positive 42. And then I'll set each little parenthesis equal to 0 and solve. X minus 7 equals 0. And when I add the 7 over, x equals 7. Okay, now remember that we can always check our answers as well. I can take this 6 and I can substitute it back in here. So I would have 36 plus 42, and then that would have to equal 6 times 13. Same thing for the 7. 7 squared would be 49 plus 42. That would have to equal 13 times 7. So you want to make sure that these answers, if you substituted them back in, still give you a true statement. So sometimes as we're solving these problems, we go through them and we get x equals a number and we just circle it or box it and move on. But we have to remember that we have to check our work too. Okay, so here's your homework to practice these concepts. Make sure you show your work. You can't just look at these problems and write an answer down. You have to show the work. Sometimes after you're factoring, really there's only one step that you have to write, but there should be a little bit of scratch work off to the side where you're finding those factors. But especially if you're solving the equations, show us that work. Or show us the box where you're doing the box method of factoring. Draw that box. Sometimes students erase their work. We don't want that. We want to see the work. Okay? So the odd answers are going to be in the back of the book, so you can check those. And the evens, of course, we'll show you the answers to those in class. And if you have any questions, come on in and see us before school.